Hello, this is Andy Billings from Circle Precision Tool. Once again, we've done a couple of videos on manufacturing a simple mechanical part. The first video was actually making a model, a three-dimensional model. The second video was actually generating a mechanical drawing using AutoDesk Inventor in both cases. And now we are once again using AutoDesk Inventor, and we are going to start the process of putting toolpaths on the part and generating some G-code. The first thing you need to do when you want to put toolpaths on a part is to define the coordinate system. In G-code, the coordinate system is defined by a G-code command called G54. It's very popular. There are I believe it's G52 through G59 are different work coordinate offset positions. Typically, you machine to G54, and that's what we're doing here. We're just doing a single work coordinate system for all our machining, and that's what we're going to do. We're going to do this video is going to be on the setup, on defining the work coordinate system, defining the stock, and then after that we'll define some tools and actually define some tool paths. So here we go. We're looking at the top of the part, and then you notice if I push here, this is the front of the part. Having the top of the part and the front of the part be correctly defined in the beginning goes a long ways to making your visual. It makes it a lot easier for you to define your coordinate system. We're going to define our coordinate system at the bottom corner of the stock, and then that way I can, and the reason we do it there is that we then on the machine, when we set the machine up, we set the coordinate system right on the corner that we orient the stock to each time we put stock into the machine. That way the coordinate system is actually attached to the vise, and it doesn't move from part to part. So you only have to define the coordinate system once, and that just makes your life a lot easier. So right now we are in the 3D modeling tab, and we're going to move over to the CAM tab. We're using Inventor's HSM stuff, and this gives us a little browser thingy up here. I expect we can get to new setup is what we want to do, and if you go up here as well, setup, and after clicking on that I instantly get this yellow box which is my stock, and this right here, and let's see if I can give you a better view, is my work coordinate system. This is G54 right now. This is the default position. So the first thing we want to do is change that default position, because that's not where we're gonna, we'll define the coordinate system here in the software, and then we will tell the machine where the coordinate system is as well, and they both have to be the same. If they're different, you don't get what you want. So I'm simply going to go over here to so with the CAM stuff, you start and you have these tabs, and you just work across these tabs, and your problems unfold in front of you and you solve them, and that's your workflow. So that's kind of nice. And right now we see with our little cube that this is the top and this is the front, making this the back corner. This is the fixed jaw on my vise, and this is where I'm going to put my coordinate system. So I've got different places, different things. I can choose parts of the model. You can do all sorts of things. You can create an Inventor assembly and put your work coordinate system on like a pair of jaws, someplace totally different than your part. Then you know, so you can do this much more complicated. I'm trying to keep this pretty straightforward and easy to visualize. So we want a stock point, and we're going to choose, this is our stock point. Now our Z is in the right direction. This is the top of our part, and the Z is going up. Our Y is in the right direction. It's going to and from away from us, and our X is in the right direction. So if this was not the case, you can click right on the arrow, and that changes your X position. This is just the opposite of what I want. Again, I can click on the arrow, put it back. It's very easy to do. Very much point and click kind of deal. So that's really nice. So I have so that's all it takes. That's my G54 work 0. It's defined now relative to my stock, and it's exactly where I want it, and everything is, all my axes is pointed in the right direction. Again, you can work coordinate system WCS. You can use these tools here as your situation gets more complicated than what I've demonstrated here. But it's really just this easy. So now we're going to move over to the next tab, which is the way the workflow works. And this is not the size of the stock that I want. So the default stocks are 40 thousandths on the side and on the top. So in fact, I don't even want to define it this way. So I can come up here to the tab and I can say add stock all sides. Okay, and I happen to know that I want a 1/4 inch on each side. And my negative Z, I'm going to actually want 0.3125, and my positive Z, I'm going to want 60 thousandths of an inch. Okay, so now with the shape of my vise and my fixturing and the piece of material that I have, that all defines these dimensions, and by adding them in this way, you're able to orient your model inside of your stock. We're going to carve it right out of there. And I think in the future they'll give you more feedback on, like for instance, you just have to know the if you want to know the total Z to cut your stock out, you have to add up the thickness of your model and these two dimensions. Okay, not rocket science and not hard, a little bit inconvenient, but just fine. And program comments, we can call this we'll call this demo bearing block. Good. Okay, so that's it. That's all there is to doing a setup. In our next video, we're going to define a 1/2 inch end mill, and we're going to go about cutting this out.